San Francisco, just days ago. Power grid fails. Traffic lights go black across the entire city. And Waymo's self-driving fleet completely shut down, dead in the streets like broken toys. But Tesla Robotaxis kept moving. No malfunction, no hesitation. They navigated the chaos as if nothing happened. How is that even possible? What does Waymo's fleet rely on that Tesla doesn't? And if a blackout can kill an entire autonomous system, what does that mean for the future everyone's betting on? Let's get the complete picture of what went down. This wasn't a minor technical glitch or a brief flicker in the grid. San Francisco's power infrastructure failed across multiple districts, taking down traffic management systems and leaving intersections completely dark. In that moment of urban chaos, two competing visions of autonomous driving faced their first real-world stress test. Waymo's fleet didn't just struggle or slow down. According to multiple reports, these vehicles became completely inoperable, frozen in place like expensive sculptures blocking traffic. They couldn't process basic navigation decisions without their network connection. Meanwhile, across those same darkened streets, Tesla's Robotaxis continued their routes as if the blackout was just another Tuesday commute. No hesitation, no malfunction, just continuous operation. Elon Musk confirmed this on X, stating that Tesla vehicles experienced zero disruptions during the outage. But this raises a question that cuts to the heart of the entire autonomous vehicle industry. What fundamental difference allowed one system to survive while the other completely collapsed? Most people don't understand how Waymo's system actually works, and that lack of understanding has allowed some critical vulnerabilities to hide in plain sight. The technology relies on high-definition maps, LiDAR sensors, and constant internet connectivity to validate position and make decisions. Think of it like a student who can only answer questions if they have access to their textbook. The knowledge isn't internalized, it's externally referenced. Tesla built their full self-driving system on a completely different foundation. Their approach trains on billions of miles of real-world driving data, teaching the AI to recognize patterns and make decisions independently. There's no dependency on perfect maps or internet connections for basic navigation. The system learns to see and react the way a human driver would, using visual processing and inference rather than pre-programmed routes and constant server check-ins. This philosophical difference might seem academic until infrastructure fails, which it inevitably does. Waymo optimized for ideal conditions with controlled variables. Tesla optimized for chaos with unpredictable variables. When the lights went out in San Francisco, only one approach proved resilient enough to handle reality. But here's what concerns me most about this incident. If Waymo's fleet can't operate during a simple power outage, what happens during natural disasters when people need transportation most? What happens during cyber attacks targeting infrastructure? What happens in developing markets where reliable connectivity isn't guaranteed? We might be building autonomous systems that only work when everything else does, which completely defeats the purpose of having resilient transportation options. While Waymo has been celebrated for their cautious, safety-first approach, the actual deployment numbers reveal a company struggling to scale beyond controlled environments. Tesla, on the other hand, has been quietly building operational capacity at a pace that should terrify their competitors. Since deploying their safety monitoring system in Austin months ago, Tesla has completed nearly 2,000 unsupervised robotaxi trips across multiple cities. These aren't carefully staged demonstrations. These are real passengers navigating real traffic in Austin, Bay Area cities like Palo Alto and Fremont, Miami, Tampa, Houston, and even Brooklyn. The expansion continues with Las Vegas, Phoenix, and Dallas already on the deployment schedule. California DMV records show something even more remarkable. Tesla has logged over 300,000 miles in California without a single recorded collision. Now, you might argue that Waymo has more total autonomous miles, and you'd be correct. But there's a crucial difference in how those miles were accumulated. Waymo operates primarily in areas they've mapped extensively with controlled conditions. Tesla is deploying across diverse environments simultaneously, gathering data from situations Waymo's system would struggle to handle. The scale of Tesla's recent expansion reveals their confidence in the technology. In the San Francisco Bay Area alone, They've grown their Robotaxi fleet from just 28 vehicles in August to 1,655 recently. That's not a typo. That's a 5,800% increase in a matter of months. They're hiring factory workers to serve as AI operators, preparing infrastructure for fully unsupervised deployment, targeted for the first quarter of 2026. But here's what really matters. Tesla estimates they could deploy 50,000 robotaxis in Austin alone if regulatory requirements didn't mandate safety supervisors. The technology is ready. The manufacturing capacity exists. The only bottleneck is regulatory approval for removing the human safety net. Once that barrier falls, Tesla's deployment curve doesn't gradually increase. It goes vertical. Elon Musk's dismissal of LiDAR as useless, inefficient, and outdated initially seemed like typical Musk hyperbole. But the San Francisco blackout validated his technical argument in the most dramatic way possible. LiDAR creates detailed 3D maps of surroundings, which sounds impressive until you consider the limitations. The sensors are expensive, require constant calibration, and struggle with adverse weather conditions like heavy rain or fog. More importantly, they become a crutch that prevents the ARI from developing true visual intelligence. Tesla's vision-only approach is significantly harder to develop. Training AI to recognize patterns and make decisions from camera inputs alone requires massive amounts of data and sophisticated neural networks. But once it works, the system becomes infinitely more adaptable. Humans don't need laser sensors to drive safely. We use our eyes and our brain to process visual information and predict behavior. Tesla is teaching AI to replicate that biological process rather than depending on external infrastructure. The blackout exposed this distinction in brutal clarity. Waymo's sensor-heavy, internet-dependent system couldn't adapt when infrastructure failed. Tesla's vision-based system kept processing visual data and making independent decisions. One approach needs the world to cooperate. The other assumes the world won't. This isn't just about technical superiority, it's about scalability. Waymo's approach might work perfectly in San Francisco, Phoenix, and Los Angeles, where they can invest heavily in infrastructure and mapping. But you can't build high-definition maps and perfect connectivity for every road on Earth. You certainly can't do it in emerging markets or rural areas where autonomous vehicles could provide the most value. Tesla's approach works anywhere there's a road and enough light for cameras to see. There's a road and enough light for cameras to see. Tesla isn't planning to simply convert more Model Y vehicles into robotaxis. They're developing a vehicle designed from the ground up for autonomous operation with no compromises for human drivers. The Cybercab eliminates the steering wheel, pedals, and most traditional controls. It's a pure two-seat urban mobility solution optimized for continuous operation and rapid manufacturing. Musk's claim that the vehicle can be assembled in just 5 seconds sounds absurd until you understand Tesla's manufacturing innovations. Every component has been engineered for high-speed production. The compact 50 kilowatt-hour battery pack provides approximately 200 to 250 miles of range, which is more than sufficient for urban routes. The aerodynamic design and lightweight construction maximize efficiency. Even the butterfly doors are designed to reduce assembly complexity while providing the futuristic aesthetic Tesla wants. The economics are transformative. Tesla estimates operating costs around 18 cents per mile compared to $1.50 to $2.50 for human-driven ride services. They're exploring a subscription model around $200 per month for unlimited rides within urban areas. Perhaps most disruptive, Tesla plans to allow private owners to add their vehicles to the Robotaxi network, keeping 70% of revenue while Tesla takes 30%. This turns every Tesla owner into a potential fleet operator. Think about what that means for deployment velocity. Waymo has to purchase, outfit, and maintain every vehicle in their fleet. Tesla can leverage millions of existing vehicles already on the road, each one potentially becoming a robotaxi overnight through a software update and regulatory approval. The company that makes a new vehicle every 30 seconds suddenly has an autonomous fleet that can scale faster than any competitor can respond. Here's my analysis of why this incident matters far beyond one night in San Francisco. The blackout didn't expose a technical failure. It exposed a design philosophy that might not survive contact with reality. Waymo built a system optimized for winning government contracts operating in premium markets, and generating impressive safety statistics in controlled environments. Tesla built a system optimized for surviving real-world chaos, scaling globally, and operating profitably without perfect infrastructure. One approach is academically impressive. The other is practically dominant. And in technology, practical usually wins even when it's messier and less elegant. There's also an uncomfortable regulatory question emerging from this incident. If a power outage can disable an entire autonomous fleet, what are the liability implications? Who's responsible when passengers are stranded during emergencies? What happens during natural disasters, evacuations, or medical emergencies when reliable transportation becomes critical? Tesla's resilience during the blackout might evolve from a competitive advantage into a regulatory requirement for autonomous systems. The timing of this incident is remarkable. Just as Tesla ramps up Robotaxi deployment, just as regulatory battles intensify, just as public confidence in autonomous vehicles faces scrutiny, a real-world stress test happens that perfectly demonstrates the fundamental weakness in Waymo's approach. When infrastructure fails, when conditions become chaotic, when the carefully controlled environment disappears, only one system kept working. Some might call that lucky timing. I call it validation of a design philosophy that prioritizes resilience over perfection. Tesla didn't build a system that works best in ideal conditions. They built a system that works especially when conditions aren't ideal. And that might be the only approach that actually scales to serve billions of people across diverse environments worldwide. So here's what that blackout really proved. Waymo built a system that needs the world to work perfectly. Tesla built a system that works when the world doesn't. That's not just a technical difference. It's the difference between a controlled experiment and a global solution. This incident revealed which approach survives real-world chaos. As autonomous vehicles scale beyond test zones into everyday life, resilience matters more than perfection. Tesla's vision-based system proved it can operate independently when infrastructure fails, when connectivity drops, when conditions become unpredictable. That's exactly what matters for the next decade of transportation. By early 2026, we'll see if Tesla's deployment speed matches their technology advantage. With cybercabs entering production and thousands of existing Teslas potentially joining the network, the scale could shift overnight. The blackout might have just shown us which company actually understands how to build for reality. What do you think? Does Waymo's approach have a path forward, or is internet dependency a fatal flaw? Drop your thoughts in the comments below. If you want more analysis on the autonomous vehicle race and Tesla's technology breakthroughs, hit that subscribe button for Tesla Zone and turn on notifications so you never miss our breakdowns. And if this changed how you see the self-driving competition, leave a like. This is Tesla Zone. We dig into what really matters in the future of transportation. Lithium-ion batteries hit thermal runaway at 360 degrees Fahrenheit. Flames reach 1,100 degrees Fahrenheit in minutes. One cell ignites the next in under 60 seconds. Tesla's 2026 aluminum ion testing reveals something different. Cells survived 480 to 570 degrees Fahrenheit without combusting. Punctured, crushed, overheated, they shut down instead of burning. The trade-off? Model 2 delivers 220 to 250 miles instead of 300. Is losing 50 to 80 miles worth eliminating garage fire anxiety completely? Most people think they understand battery fires, but there's a fundamental difference that changes everything. When gasoline catches fire, you spray foam or water, cut off the oxygen, and it's done. Lithium-ion batteries don't work that way. At 360 degrees Fahrenheit, the polymer separator inside each cell begins melting. Push it to 390 degrees, and the cathode materials start releasing oxygen internally. This is the critical point. The fire doesn't need outside air to sustain itself. The battery is generating its own oxygen, feeding its own combustion from within. What happens next